basically it's hide in a crowd. You find, and this is kind of context dependent. It depends upon what kind of environment you're in and what traffic is going on between the machines. You kind of have to be flexible. And in that sense, maybe your rootkit would have to separate mechanism from policy. Maybe you'd be able to cater to several different, scenarios, and your code would just have to be able to detect which one is appropriate and use that. And as you can see, people have jokingly told me this is a 1990s approach to doing stuff. There's a FRAC article on ICMP tunneling that came out in the 1990s. So there are countermeasures. So we looked at concealment. We went with shellcode. We wanted to be able to survive reboots. So we went with a secondary backup rootkit and the heartbeat generated through protocol tunneling. What kind of countermeasures do the white hats have that they can use? So Jesse Kornblum pointed out the rootkit paradox. A rootkit wants to execute, but at the same time, it wants to remain hidden. And that's a problem because, like I said, you can only hide so much before you're not running anymore. So if the operating system can find the rootkit, the code to execute it, then the investigator can find it too. And I would add that a rootkit just doesn't want to execute, it also wants to communicate with the outside. And that's kind of another kind of linchpin. Most rootkits will establish some sort of covert channel with a remote party. Now, again, and because of this, it will be possible ultimately to see something going on. But just because it's possible doesn't mean it's going to be easy. It's possible to make a lot of money in the stock market. All you got to do is buy low and sell high. But that doesn't mean it's easy in practice. So, like I said, modifying the system is a common way of hiding. You launch your module, then you modify the system to hide whatever you've launched and everything else. And so, most security software will try to detect local modification. This product HookSafe that came out a little while back. It's basically a watchdog hypervisor, and it monitors guest operating systems for these little modifications that happen as a result of your rootkit wanting to hide. But not all hooks are the same. Some hooks are static and can be easily detected, but some aren't as easy. Some are based on dynamic objects, which it's much harder to say, whether something's been subverted or not, or whether this address is legitimate or it isn't. So this is why I prefer callbacks. They're generated dynamically. They're all over the place, and it's not always obvious what's legitimate and what isn't. And then there's also the fact that you could also subvert the components that they're testing for modification. There was Windows has got a feature called kernel patch protection, KPP, and there was an arms race for a while. There was an online magazine called Uninformed that had a series of articles about subverting patch protection, and they went back and forth, and Microsoft would realize what was going on, and they tried to modify their code, and it was interesting. So you can also, another tack to take is vision in the police department. And I think ultimately, in terms of where things are going, I think network security monitoring is going to be a big deal because it's a lot. You can hide stuff on a local machine. You can interfere with the process of data collection on a machine as a rootkit. But it's a lot harder on the network because it's more passive. If you're doing a full content data capture and maybe you're on a span port or something, you capture everything, and it's a lot harder to kind of implement some sort of subversion and make it harder for the investigator because they see everything. But then when it comes down to it, I think foiling the forensic investigator, it's all about buying time, because ultimately, they have a budget, and a lot of times they're constrained by kind of the organizational shortcomings of a bureaucracy, and having a limited budget, and so, if you read this blog by Balick, he basically says as much, that they have limited resources. And you can kind of take advantage of this. And you just have to buy time. You have to make it difficult enough that they don't have the resources to really go down and find you. So my kind of solutions here, my middle paths, obviously there's some shortcomings to them and there's room for improvement. The heartbeat that I do injects new packets into the network stream, and that is problematic because there's new stuff that pops up, and an experienced eye will catch this. So one answer to this is don't inject new packets, don't create new network traffic. Embed yourself in embed your data that you're exfiltrating or your command that you're issuing and the response you're getting, embed that in the packets that are already going back and forth across the network. Embed your stuff steganographically inside the existing traffic. And that's kind of the idea behind a passive covert channel. And there's been a lot of work done on that, which is pretty cool, pretty bleeding edge. Obviously, the problem with it is that you kind of throttles the amount of information. If you're twiddling ISN numbers on packets, there's kind of gives you an upper bound in terms of the rate at which you can move data in and out. So for a password, for the password hashes, if you were filtering those out, that'd be pretty easy. But for a large database table, it'd be a little more problematic. So for command and control, one way to generalize the idea of a rootkit and to kind of make it into a framework would be to use a kernel mode virtual machine. That way you could abstract your logic into a platform neutral bytecode and then implement the rest of it in kernel mode shellcode. And that would give you some degree of portability. And even more important, bytecode, the virtual machine bytecode tends to lend itself towards dynamic loading. And in terms of a rootkit, this means runtime extensions, where there's going to be a packet sniffer or a keylogger or some sort of instance-specific attack where you're going to go after some specific security software package. And that kind of is a way for you to add features and give your rootkit some flexibility. And finally, runtime deployment, the initial scenario that I introduced was basically using an exploited user mode process and then funneling the kernel mode shellcode down through device I/O control. And that's kind of a somewhat awkward, and extended approach. A more direct approach would be just to leverage a buggy kernel mode driver that's already on the system that has something you can exploit. And that's probably the best way to load the shellcode in kernel mode is just to find a buggy driver and to load, basically exploit that, some sort of buffer overflow or something, and load your code that way. And if you want to download the source code to this kind of proof of concept stuff that I've done, you can go to my website at Below Gotham, and I've also written a book that details other stuff that I can't fit into an hour. And that's also, you can go on Amazon or go to my website. There's some information on it. Thank you very much. Any questions?
Just a comment, I found it interesting. You're saying you're going to turn off all these features of the compiler in your shellcode. Does it make you uncomfortable that you might be writing vulnerable exploits?
Yeah, well, absolutely. What did Stan Lee say, or was it Spider-Man? He said, "With great power comes great responsibility." Right? I can see exactly what you're saying. So it's the cost of admittance. You just have to be careful. That's a good point, though. Thank you. Anyone else? Ooh.
Yeah, this is kind of an uninformed question, but you did a great job, I thought, of outlining the approach that you would take, writing the perfect rootkit, and then the various mitigations people might apply to find it. And those sounded awfully labor-intensive to me.
Oh my God, yes. And that's one of the reasons that it's all about buying time with anti-forensics, because it's a labor-intensive process. As a system administrator, I find a machine that's compromised. My first response, as a system administrator, with other people breathing down my neck, wanting help, is to crash and burn. The scorched earth policy. You flatten and re-image. That's my first response. I would love to say, okay, there's malware on here. Let's take it off. Let's analyze it. Let's take a whole week. We can reverse it and we can see what it's doing. Do a behavioral analysis. Get a sandbox. Do other stuff. Oh my God, it'd be so much fun.